So I did not got the offer letter for PhD admission at IISc, but I got offers from other IITs. Then I again applied for IISc PhD admission in mid-year cycle, which happens in November. So again I got the offer letter, and this time I did not apply in IAP department. I chose Materials Engineering department as third preference. So my first preference was CeNSE, Physics and Materials Engineering. तो चलिए शुरू करते हैं. CeNSE and Physics I have already explained how they take interviews, but this time it was quite different. अगस्त सेमेस्टर में क्या होता है कि सारे प्रोफेसर स्टूडेंट लेते हैं, पर दिसंबर साइकिल में उतने सीट्स नहीं होते हैं. लाइक 5 to 6 will be there per department. So this time CeNSE has only one round of interview unlike the last time. और इस बार क्या था कि आपको प्रेफरेंस देना था पहले ही प्रोफेसर्स के कि आपको किसके अंडर काम करना है. सो आई गिव द प्रेफरेंस एंड on the basis of preference you will get the panel for the interview. So there were only 2 panels this time because 6 or 7 professors were taking students in the mid-year cycle. ठीक है, जिनके पास सीट्स होता है एक्स्ट्रा वो मिड ईयर साइकिल में स्टूडेंट्स को लेते हैं, तो बस वही लोग थे इंटरव्यू लेने के लिए. सो दिस टाइम शायद इंटरव्यू मेरा 18th of November को था. सो हाउ इट वेंट नाउ लेट्स सी. सो दे आस्क्ड मी अबाउट माई इंटरेस्ट एंड इंट्रोडक्शन. सेम कहानी. आई टोल्ड देम device physics, semiconductor device physics and fabrication. Okay. Then the immediate question they asked was, if you are given a material, any material, you don't know what is that material. Okay? How will you know whether it is semiconductor or metal or insulator? So I told them the answer that I will measure the R versus T. I will measure the resistance of that material as a function of temperature. So for metal it will look like this. This is some rho naught, and for semiconductor it will go down as we increase the temperature. And for insulator the resistance will be too large, so we can know it is the insulator. Okay. This is the typical scenario. They will ask the question from your previous answers. So the next question was, in case of metals, why there is some resistivity at 0 Kelvin? There should be no resistivity at 0 Kelvin. Electron should flow without any resistance at 0 Kelvin. Because I have drawn the graph like this, because here is some resistance. I told them that for metals there is a residual resistance at T equal to 0 Kelvin, and that comes due to defects and impurities in metals. Because in metals you cannot purify the metal completely. There will be some defects and impurities. There will be some finite defects and impurities in the metals, and that will contribute to the resistance. Even if I go to 0 Kelvin temperature and there is no lattice vibrations and all and phonons, but there will be impurities and defects in the metals. Due to that, electron will get scattered and there will be some resistance in the way of electrons, and that's why this is not 0 at T equal to 0 Kelvin. That was my answer. So then they asked, explain the origin of a resistance according to a Drude model. So I told them a Drude model assumes like kinetic theory of gases. Electrons are like free particles of gases and they are moving freely, but their velocity and their movement are random. So they are getting scattered randomly due to other electrons and atoms. So I explained them the concept of collision. They collide and there is a mean free path, and they scatter due to temperature also. So if you don't apply an electric field, then there will be no current passing through it, because electrons move in a random fashion, and due to that random motion in all the direction, there will be no current. And if we apply a voltage, then they will drift to any particular direction opposite to the direction of the electric field basically. But this movement will be there, they will not stop. That collisions and scattering and all will be there. So due to that there will be scattering and there will be resistance, but current will flow. So this was all I explained, the origin of resistance and all. उसके बाद they asked, how will you measure the resistivity? So the same experiment I told in physics department 6 months ago, same experiment I told, 4 probe method I will use to measure the resistivity of the material. Then the same question they asked, everyone will ask this question, why 4 probe and not 2 probe? So here I will explain you a bit more in detail. If your contact resistance is comparable to the resistance of the material, then the total resistance will be added and you will not get the accurate resistance of the material if you use 2 probe. This is a 2 probe and this is the 4 probe, and the current will flow from this to this outer wires, and current won't flow in the inner probes because it has infinite resistance, the voltmeter, and you will get more accurate data using 4 probes. Now they asked, how does it eliminate the contact resistance? So then I explained them the same concept. Voltmeter has infinite impedance and no current flows, so no RC. So now they came to Hall effect. So they told to explain me the Hall effects with all the diagrams and all. So I explained them considering a semiconductor material and what happens, how it happens. Okay? We apply voltage to a semiconductor material electrons flow opposite to the direction of electric field. And if we apply magnetic field perpendicular to the direction of current, then we get the voltage in perpendicular direction to both current and magnetic fields. So this is the diagram. This is the current flowing here, this direction, and magnetic field is in Z direction. So we will get a Hall voltage here, VH, along this direction, up and down, because electron will get some force due to this magnetic field, and they will start getting accumulated in the upper surface or lower surface depending on the direction. So I explained everything about the Hall effect. Okay, told me to show the forces acting on electrons and hole explicitly, and then they asked the charger will be accumulating at the top surface or stop, like the charge will continue accumulating forever or they will stop accumulating. So I told them they will stop accumulating because electron will get repelled after some time. And how? Because electron is flowing in this direction. Okay, velocity, this is my B, so this is upward is my electron going due to B. So velocity is B, this is my electron velocity is B. So V cross B is this. The electron will go in upward direction. Okay, now if electron will go in upward direction, there is a charge difference between upper surface and lower surface. So we will get electric field or a Hall voltage between the top and bottom surface, and this will create an electric field. Now this electric field will create a force on electron. Already there is a force on electron due to magnetic field, and these two forces will be in equilibrium after some time. So the electron will stop getting accumulated after some time. Now they ask a very good question. ठीक है, ये क्वेश्चन आपको सोचना चाहिए कि इसका आंसर क्या होगा. So let us say I am not putting the voltmeter probes at exactly the same position. तो ये मेरा सेमीकंडक्टर मटेरियल, मैंने अपर प्रोब यहाँ रखा है, लेकिन लोअर प्रोब सेम पॉइंट पे नहीं है जैसे कि अपर प्रोब, मतलब सेम एक्स पे नहीं है. लेट्स से दिस इज माय मटेरियल एंड दिस इज माय एक्स एक्सिस, दिस इज माय वाई. आई प्रूव द अपर प्रोब हियर एंड लोअर प्रोब हियर, नॉट एट द सेम एक्स पोजिशन. सो ही आस्क्ड what will change, or there will be no change in the Hall voltage whatever I am measuring. So I said there will be a change because there will be a voltage difference between these 2 points, this point and this point, and this voltage difference will get added if I am measuring the voltage between these two surfaces, this surface and this surface, and this voltage is Vx and this voltage will be added in the Hall voltage. तो हमको Hall voltage का एक increased value मिलेगा. Okay, he told me how, can you show it and find an expression for this Vx and then the total V prime. So I tried deriving the voltage due to this difference in the distance and what will be the final formula of Hall voltage. ठीक है, फाइनली एक इक्वेशन पे अराइव हुए थे हम, बट हमको याद नहीं वो इक्वेशन क्या था. एंड वी कैन ट्राई, बट अभी ज़्यादा वीडियो को लंबा नहीं करेंगे. देन द क्वेश्चन वाज, द मेन क्वेश्चन वाज, हाउ विल यू सॉल्व दिस प्रॉब्लम. मतलब इफ़ यू आर पुटिंग द probes at different distances, how will you solve the problem? Because you don't want to measure that extra voltage that is coming due to inaccurate placement of the probe. So I told them that we will try to align the probes at the same point, but he told them you cannot align the probes at the same point at the macro level. So can you think of any method or something you can do about it to eliminate this कि हमें सिर्फ Hall voltage मिले accurate, ना कि extra voltage. So I thought and thought for 2-3 minutes, but I did not have any answer. उन्हें बोला okay, it's okay. But answer क्या होगा उसका हमें बताया था थोड़ा सा. This is my material and I'm measuring the Hall voltage like this. Okay. And this is my magnetic field out of the plane. And I will apply the magnetic field 2 times. One in out of the plane and one inside the plane, opposite to this V prime. And for both B, if I'm changing the magnetic field direction, my Hall voltage sign will change only. So let's say this is V1, which is VH1 plus Vx, and V2 will be Hall voltage 2 plus Vx. So this will be just reversed sign of this. So we can subtract this from this and this will be eliminated and we will get 2 times Hall voltage. So we can get the Hall voltage very accurately without having this voltage added. This was the answer. When I came out of the interview room, I searched on internet and then I found this answer. उस टाइम पे हम सोच नहीं पाए. ठीक है. And then ये लास्ट क्वेश्चन नहीं था, लास्ट क्वेश्चन ये था, they were having a box, white color box, and they gave that box to me and they gave a multimeter. Okay, and they told me कि point with this multimeter, do whatever you want and find what is inside this box. Okay, so I tried and I measured some resistance, capacitance, then inductance, and I came to a conclusion that there was a resistor and a capacitor inside the box. Maybe there is a resistor and a capacitor or a coupled RC circuit in the box. This was the whole interview. in CeNSE department in the mid-year cycle. Now let's move on to physics department. This time I gave interview first at CeNSE and then at physics, because physics department interview was 2 days after the CeNSE interview. So शुरू करते हैं physics department का. This time I gave only in experimental condensed matter, no theoretical condensed matter, because theoretical condensed matter में seats ही नहीं थे, तो उसका इंटरव्यू ही नहीं हुआ. So only experimental condensed matter physics interview, experimental CMP. So let's see. First again introduction. See, the physics department, both the times they asked same thing, what experiment you did. So if you are coming to physics department at IISc, prepare 1 or 2 experiments very well, that you know everything about that experiment and every theory related to that experiment. Okay. So they asked any experiment you would like to explain. So I told them Hall effect, because Hall effect I had revised so much. Now they asked simple question first, like how VH, yani Hall voltage, is getting generated. So I explained them. Okay, the same thing. Then how will you find the number of charge carriers? Okay, so I told them we will get the number of charge carriers through this relation, R equal to 1 by n, and we will get R from the Hall voltage. We will measure the Hall voltage and then we'll get the R, and from R we can get the number of charge carriers in the semiconductor or metal. So now they ask the next question as, if you have an intrinsic semiconductor, number of electrons is equal to number of holes, so will you get the Hall voltage for this intrinsic semiconductor? I was confused, will you get or not. First I told them no, but they told me to think and asked me how, and I told them that there are equal number of electrons and equal number of holes, so why we will get any potential difference between the top and bottom surface if equal number of charges are there. And then I told, okay, we will get the Hall voltage. And how? Because the Hall voltage not only depends on the number of charge carriers but also on the mobility of charge carriers. Typically in intrinsic semiconductors, the electron mobility is higher than the holes, so we will get the Hall voltage in intrinsic semiconductor also. Then they asked what is the band gap of silicon. Now you remember I tell 1.1 electron volt. Now they asked me to draw the energy band diagram of silicon, the EK diagram. So I drew, and क्योंकि ये indirect band gap semiconductor है तो EC और EP same K पे नहीं होंगे. Then they asked how the transition will happen and all. Then I showed them the transition. They will transition in 2 steps. Well, first they will transition from here to here, then here to here, so that the momentum can get conserved. So after that they asked, if I give energy more than the band gap of the semiconductor, let's say, or equal to the band gap of semiconductor, that is for silicon is 1.1 electron volt. If I give them exact 1.1 electron volt, will it show photoluminescence or not? Photoluminescence means just the emission of light. Okay, so I told them yes, it will show photoluminescence or emission of light. If I only supply 1.1 electron volt, it will go to here, not only here. Okay, because this energy is equal to this, so to conserve momentum this has to go here. But if I supply energy equal to this, it can go to this level, and then it can go to this, and then it will come back through the same process. And if it comes back, it will emit light equal to the band gap, and it will emit light of energy equal to the band gap of the silicon. So it shows transition. Okay, so let's move to the next question. So they asked the next question as, let's say you have an ice cube at 0 degrees Celsius and you put it on a table at room temperature. So draw the temperature versus time graph for this system, for this ice cube. How will the temperature change with respect to time? So I told them I haven't devised this kind of topics, but it will, okay, just try to think. Don't worry and don't get afraid. Just try to think what will happen and draw the graph of temperature versus time simply. So I thought for a few seconds and came up with this graph. At 0 degrees Celsius, first the heat will be utilized from the surroundings to change its phase from solid to liquid, and at that time temperature doesn't increase, and this is the latent heat. Temperature will remain constant. After coming to liquid phase, the temperature will increase gradually, because the room temperature is let's say 25 degrees Celsius, so room temperature पे आएगा liquid. And then he asked, what if we heat it again? So if we heat it again, the temperature will increase, and at boiling point, let's say this is not correct, I guess this will be like this, not this, so go like this. This will be at 100 degree. So again at 100 degrees Celsius, latent heat of vaporization will come. The temperature won't increase, all the heat will go into changing the phase from liquid to gaseous state, and then again the temperature will increase. So like that I do the graph, and this was the last question they asked, and the interview got ended. So now let's go to the last interview of IISc and of this video, of course. So the last interview I gave was at materials engineering department, and this interview happened on the next day. Yeah, very same. There were 2 panels. I went to the first panel. They asked about my introduction, okay, and interest. I told them solid state physics, semiconductor devices, solar cells and all. They always have your application form, okay, so they can see your preferences, which departments you have filled in. So they saw my department preference and asked how were other interviews. So I told them that it was decent. They directly sent me to board and they asked me to draw the crystal structure of silicon. So I drew it, okay. Then they asked which lattice is this. So I told them it is a diamond cubic structure, but this is formed using 2FCC lattice. You can interpenetrate 2FCC lattice at 1/4, 1/4, 1/4 distances, and then you can get the silicon structure or the diamond structure. So let me draw. This is like this. The atoms are here, and FCC lattice here, and then 4 atoms are at body diagonals. So the 4 atoms are at 1/4, 1/4, 1/4 distance from origin. So total 8 atoms are there. They asked the next question as what will be the XRD pattern if you have an NaCl crystal. So I told them that NaCl has FCC structure, and so the XRD pattern will have only the peaks due to all odd planes or all even planes, not like 1 to 1 planes. Okay, this is not possible for FCC structure. But then they asked how do you get that. So I told them that it comes from geometrical structure factor, and we can calculate it for different lattices. So they told me to write it and explain. I wrote the formula for geometrical structure factor like this, and here HKLs represent the Miller indices of the planes, and XJ, YJ and ZJ represents the position of atoms or motifs. Okay, so for FCC we have positions at half, half, 0, then 0, half, half, and then half, 0, half. So if you put all those values and sum, this structural factor will come out to be 4f or 0. 4f will come for all odd and even functions, and it will come to 0 if they are not like this, if they are mixed. So okay, then they told me to write this structural factor not for FCC only, but for NaCl explicitly, not any general FCC lattice. So I did not know that time कि NaCl के लिए कैसे लिखते हैं geometrical structure factor. You have to find separately for Na and then separately for chlorine, and then you have to add this or combine this. Then you will get the total geometrical structure factor for NaCl crystal. They asked me to write it or derive it, but I could not do it. Then they moved on to the next question. So the next question was, for a solar cell, what are the 3 things that you look for to maximize the efficiency of the solar cell? So I told them that first is band gap, and I was thinking I could not tell all the 3. So they asked how much band gap is optimal for solar cells. So I told them 2 to 3 electron volts, but it was wrong, I guess. They were not satisfied. Then they moved to the next question, and they told me, if I give you a material, how will you find it is a n-type or p-type or a metal? And this was the same question which was asked in CeNSE department. So I told them I will do a Hall measurement. Through that I can get to know that it is n-type or p-type or a metal. I'll measure the Hall voltage, and through that I will get the Hall coefficient. And if the Hall coefficient is negative, this Hall coefficient is 1 by Ne, and it is negative for n-type, positive for p-type, and also for metal it is negative, because metals have majority charge carriers as electrons, so they will be negative. So to distinguish between metals and n-type, I can do resistivity measurement. I can measure resistance as a function of temperature, and we can get different graphs for n-type and metals. For n-type, my resistivity will decrease with increase in temperature, and for metals it will increase. For semiconductor it will decrease, n-type and metals. So I told them this answer. Okay, then they asked the same question as asked in physics department. So they are related questions if you say the same topic. So what will happen if you do the same measurement on an intrinsic semiconductor? So as I already gave the interview in physics department, so I knew this answer, and I told them that Hall voltage will be there because it is not depending only on number of charge carriers, it also depends on the mobility of charge carriers. Then this was the last question. They told me to plot a graph of x square and x cube on the same axis. So I tried plotting. So I just thought कि oh wow, they gave me a very simple graph. बहुत simple graph दिया है. चलो x square का ग्राफ बनाना है, x का ग्राफ बनाना है. x square थोड़ा कम steeper होगा and x cube थोड़ा ज़्यादा steep होगा. Curvature ज़्यादा होगा. So I drew this, but it was not so correct because they wanted to check what I'm doing at x equal to 1 and at x equal to less than 1. So at x equal to 1, both x square and x cube will be same, but at x less than 1, x cube will be less than x square, and x greater than 1, x cube will be greater than x square. So you should show this on the graph. Okay, so the interview ended like this with the graph at materials engineering department at IISc. Okay, so this was all about the interview experiences and all the questions asked in my interview at 4 different departments. So prepare well the concepts and brush up your ideas, and see you in the next video. Tab tak ke liye, bye.